Hello students, welcome to our online open class. We're now learning the part programming design of the Happy Pig. There are a total of 7 processes in the product. In fact, 7 processing tasks are 7 machining tasks. Students have already independently learned the machining methods of other types of products before the class. Now, we start the learning of the first processes of this product, the rose machining of the top surface. Let's repeat the 6 processes of creating tools, creating the workpiece coordinate system, creating the blanks, compiling the programming, simulating machining, and optimizing the programming. When machining this product, we must adopt the upmilling method and follow the principle of dips, first to ensure the surface roughness and dimensional accuracy of the product. Also, the machining allowance of the bottom and side can only be within 0.5 mm. The second problem that students need to pay attention to when programming is to remember to select all the machining surface in order to prevent missing machining surface. Through frequent operation, we will understand the need to simplify complex tasks, repeatedly perform simple tasks, and cultivate a meticulous and patient craftsman spirit. The programming steps are as follows. First, enter the UG machining interface and open the part machining option. Select the appropriate tool according to the product's technical requirements and create all types of tools. Here, we need to create D16R2 and D8R2 two tools. Second, create the machining coordinate system. First, measure the basic dimension of the part. Then enter the geometry creation interface and create the MCS coordinate system. The coordinate system must be set on the upper surface of the workpiece, and the name of the coordinate system can be set arbitrarily. Third, create the process. This process adopts the cavity milling method, specify the cutting area, and set the tool path. Fourth, generate the tool path and tool path simulation. For detailed operation specifics, please watch the skill operation. Let's begin the skill operation demonstration for the top surface rose machining procedure. First, open the original file, enter the application module, click Machining, click Surface Machining, and then OK. Click on the Geometry view. First, go to the Machine view and click Create Tool. Name the tool D16R2. And OK. Set the diameter to 16 mm and the lower radius to 2 mm. Then click OK again. The first tool is created. Next, create the second tool. With the same settings, name it D4R2. And click OK. Set the diameter to 4 mm and the lower radius to 2 mm, and click OK. The fine machining tool creation is complete. For the ball end mill, name the tool Q3 and OK. You can set a diameter of 3 mm. Next, create geometry and a coordinate system. Naming the system A and set the safety distance to 10. Click OK. To view the coordinate system, check in the Geometry view. Next, click Create Geometry, create Workpiece. Find the already created A in the geometry. Name it B, and click OK. Pick the workpiece. Click OK. Pick the blank. Choose Containment Block. Set Z to positive 1 mm. And click OK again. In CAM programming, the fundamental steps include analysis of machining process, toolpath generation and editing, post-processing, and machining simulation. The general principles for the sequence of machining operations are typically based on establishing references first, followed by rosin before finishing, facing before drilling, and primary operations before secondary ones. Next, create process. Click on Cavity Milling. Choose the 16 mm diameter tool. Select Geometry B. Choose Rosin. Name it Top Surface Rose Machining Procedure. And click OK. Pick the machining surface. You can use shortcuts like CTRL plus ALT plus T for the top view, and frame select all surface. Switch to the isometric view, and click OK. After selection, choose Follow Part as the cutting mode. Set plane diameter to 15%. Constant maximum distance to 1 mm. Select sequential order. Layer first as the cutting parameters. Set allowance to 0.5 mm. And the blank allowance to 0.5 mm, and click OK. Other parameters can be default. Click OK. Then go to non-cutting parameters. Which can be left as default. And click OK. Click Generate. And the toolpath is calculated. Then click OK again. Click on the process, right-click to find toolpath. Then click OK. In the 3D dynamic, adjust the animation speed to 2, and click Play. In CNC process parameters, the selection of step over is crucial. For rose machining, the step over is typically chosen as a function of tool diameter. The depth of cavity milling is usually defined by the geometry of raw material and the part or can be customized. When performing cavity milling, the optimal approach for tool engagement and retraction is often considered in an arc manner. Accelerate the animation speed. Then click OK. Next, right-click to access post-processing. Select the corresponding post-processing file, set to metric or imperial, and click OK again. The CNC machining program is generated and can be modified and optimized for existing equipment. The skill operation is now complete. In today's class, we completed the first process of the Happy Pig part programming design on the UG software platform. During the programming process, we used the cavity milling method. This task involves the comprehensive processing of curved surface. Students need to practice repeatedly to achieve the effect of applying the learned skills to similar tasks. Based on the operation demonstration, students can practice on their own, follow the requirements of the programmer and technician to set the optimal parameters, and generate the best program file in the post-processing. Thank you all for listening.